Hey everybody, this is Patty Minch, and this is my lesson on wiring wearable technology. In this lesson, students create a piece of wearable technology to help cave explorers see in the dark. This is inspired by the Thailand cave rescues. I thought it'd be an interesting way to get students engaged in thinking about the problem. Within this lesson plan, the path of learning goes like this. Students start with a PhET simulation where they explore and experiment using the simulation, and then they use that information and their newfound understanding to create a paper circuit to see if they can get an LED to light up in real life. These two sections kind of fit within the ask steps of the engineering design process, where they're identifying the need and they are researching how they can fulfill it. Lastly, students then take what they've learned through the simulation and the paper circuit to create a wearable piece of technology. So students would start in the PhET simulation. Here they discover how circuits function and can explore the different configurations and materials and how they affect the circuit. You can start to see some of the limitations of the circuit, what to do, what not to do. In the top right corner, you can see students would understand how a short would work. And then in the later stages, they can refer back to what they've learned in the simulation and use it to test out ideas before they construct their design entirely. So if they have an idea of how they want something to work, they can try it on the simulation first before they use some of their resources and potentially damage their resources. On the bottom right hand corner, you can see a really simple paper circuit that I created just to solidify my understanding of how circuits work if I were a student. And as you can see too, the light bulb was not very bright, and so one change that I made to my own resources for this lesson was to go out and buy a slightly stronger LED, just so if students were doing this and they were creating a piece of technology to help somebody see in the dark, I figured that they would feel a little bit more satisfaction if they used a light bulb that was stronger, that actually helped somebody see in the dark. So you'll see that in a little bit. So off to the imagine stage, developing some possible solutions. I got this idea from the little chain that we got, the little necklace. It reminded me of the chains that you put on glasses and keep them around your neck so you don't lose them. And I also got the idea from the 3D glasses that we got in our kits, just to create a either a pair of glasses or a hat or something that had light bulbs on it. So I decided to go with the hat. So I got an old hat from my closet and I drew up some ideas. And so my original idea was to run some wires through the inner seaming of the hat, and then have the light bulb on the front brim, and then just attach the battery to the back of it. So with my plan, I punched some small holes into the sides of the hat so that I could run the wires into the inner seamings of it, and then I have the wires coming out to the back a little bit. I connected the battery connector to both ends of the wire, and then on the other end of the brim of the hat, I attached my new LED bulb. And I taped everything up really nicely so none of the wire was exposed. So you can see a more final product. You can see the tape along the brim of the hat to keep the wires in place and to tape up the connection a little bit. I also created a way of measuring the brightness in a little bit more of a standardized way. So I put a section for the light bulb would be about here, 6 inches away. We have the sensor, and then all of this got put under a cardboard box, so the only light that the sensor was reading was from the light bulb itself. And so you can see in an evaluation, it worked out pretty well. The light sensor picked it up at 29.1, so my next task was to go back and try to improve upon the initial reading. So thinking about flashlights and headlights in cars, I realized that a lot of them have a reflective material behind them. So I put a layer of tinfoil above the light bulb and tried it again. And in doing that, I improved the reading by about 2 times. So the light sensor picked that up at about 50.6, and then improved upon that even more. I put even more reflective material along the bottom of it, and that improved it even more. So here you can see the final product to the right. I'm a proud owner of a brand new caving hat. So looking at my evaluation of my lesson, the only thing that I have a somewhat rating for would be the integration of important science and math grade level content. Obviously, it hits the science content with creating circuits, but I didn't integrate very much math into it. I'm not sure how I could have done that except for maybe analyzing the readings or displaying the readings in some other way. So if you guys have any feedback, I'd appreciate that. But everything else, it presents a real problem. I think the students would relate to the problem being about the same age as the students who were trapped in the cave. And it definitely allows for multiple acceptable and creative approaches for this problem. I was thinking students could make some sort of a watch or a bracelet that had a light on it, or goggles like I had before, or a helmet. So there are lots of different ways that this could be done. It clearly uses the design process. It's student-centered. Students would work in groups through this. They have to create a prototype. Through the use of PhET simulations, I believe that students understand the role of technology throughout this lesson. It includes testing the solution, evaluating the results, and finally, I would have students communicate their design by creating a presentation to display to the class how they worked through the engineering design process. Thanks for all your feedback throughout the course, and I wish you guys the best of luck.